So here the quick introduction for trees. So in this video we're only gonna cover some of the terminology. A tree is a nonlinear data structure where nodes are organized in a hierarchy, and this could be an example of a tree. It's made of nodes and some edges. Nodes could be a piece of data, and edges represent the relation of between of two nodes. A real-life example of a tree is a family tree, and maybe we're at the node D. So B is a parent, E is your brother or sister, A is your grandparent, and C can be an aunt or uncle, and F is your cousin. A tree could be an example for making a website or programming or something like File Explorer, databases, DNS, and HTML DOM. The top of the tree is called the root. The root node does not have any incoming edges, only outgoing edges. And any nodes at the bottom of the tree is called the leaf node. They don't have any outgoing edges. And also they do have an incoming edges. And the branch node is in the middle, and they have incoming and outgoing edges. And any nodes with outgoing edges, it's called the parent. And in any node with incoming edges, it's called the child. And middle node can be parent or child if they have both incoming edges and outgoing edges. And if you see both children sharing a one parent, it's called siblings. And D and E both sharing parents at B. So D and E are siblings, and both so B and C. And these two nodes are siblings. It's just a normal family tree. A subtree is a smaller tree held within a larger tree. You could say that this portion is a subtree. The size of the tree is equal of the number of the nodes. So what's the size of the tree? We have 1 node, 2 node, 3 node, 4 node, 5 node, and 6 node. And the size of the tree is 6.
So let's talk about tree traversal. Tree traversal is the process of visiting all the nodes of the tree. We don't have random access, so we begin at the root node and follow the certain procedure to visit all the nodes of the tree. And there's the tree that we are going to talk about: in order, post order, and pre-order traversal. In this example, we will be working with a binary tree, not a binary search tree, because this value is not in binary search tree order. So each node has at most 2 children, a left node and a right node. Let's begin with an in-order traversal. Here's a recursive method that we will navigate a tree in order. Using recursion, we visit as many left nodes as we can, followed by the root node, and then any right nodes. The entry point is always the root, and using recursion, we will go as far left as we can. So we go from A to B to D. So we will mark this node as visited, then visit the root node next in the right node. Since we can't go left anymore, we are going to visit the root node A. All that's left is go to right, so we'll go to C. However, we can go left, so we'll visit F first, then C, then G. So this is in order traversal. When used in the context of a binary search tree, we will visit all of these nodes in non-decreasing order. So again, that was D, B, E, A, F, C, G. We go left, root, right, and use that method again.
And here's the post order traversal. It's used to delete a tree from leaf to root. And we'll follow this pattern: left, right, root. We will use recursion to visit left children and the right children. And the root. Go from A to B and the D. Then we go right using recursion. We go to D to E and root. Left, right, root. Then we go back up, go as far right as we can re-encounter we did. So we mark F is visited and G right root, left right root. And all what's left is root node. So that is post order traversal. It's used to delete a tree from left to root.
Lastly, we have pre-order traversal. Pre-order traversal is used to create a copy of a tree. We visit any root nodes first, then left, then right. So, we mark A as a visited or entry point, then visit the left child, and we will continue to the left, then go right. So we can't go left anymore, we're going to right, Mark the route as a visited, then left, then right. This is used to create a copy of the tree. But in order to copy of the tree, you need to create a root node and branch node to hold the leaves. So again, root, left, still left, right, root, left, and right. A, B, D, E, C, F, G. That is a pre-order traversal. It used to create a copy of a tree. Well, okay then everybody.